A military map is simple and easy to understand once you know how to apply certain basic principles. This man, for example, is in unfamiliar territory. He wishes to identify his present location and plan a route which will take him back to his platoon in a small town some distance away. On his military map, if he knows how to read and use it, the soldier will find all of the information necessary to solve his problem. But before he can be certain that the information he reads from the map is correct as it relates to his present position, he must orient the map. To orient means to adjust. Thus, to orient a map, you place it in a horizontal or flat position and then adjust or turn it until north, which is always at the top of the military map, is pointed toward north on the ground. When this is done, the symbols on the map will occupy the same relative positions that the features they represent occupy on the ground. In this way, you can locate and identify any visible features the map depicts, as well as determine the directions to features which lie beyond your range of vision. There are several ways to orient a map, but one of the fastest and most accurate is with a compass. This is a LENSATIC compass, commonly issued for use in the field. It takes its name from the magnifying lens, which is mounted in this arm. The most important features of this compass are, first, a sighting device consisting of this sighting slot and this sighting wire, and second, a free-floating dial indicator. Although you can see that the dial has lines and numbers in both black and red, we will be concerned only with the red markings around the inner edge of the dial. These red figures indicate degrees, the most commonly used unit of angular measurement in map reading. A circle is divided into 360 degrees. If you stand in its center, these directions, as indicated by the degree marks, radiate out from you like the spokes of a wheel. The compass dial, due to lack of space, is marked in 5-degree graduations, and every 20th degree is numbered. The magnetic arrow on the floating dial always points to magnetic north, so each degree mark around the dial indicates a specific direction away from magnetic north. Thus, by looking out from the center of the circle, or sighting across the center and over a degree mark, you can identify a direction. By holding the compass to your eye in this manner, and lining up the sighting slot, the sighting wire, and your target, you can read the direction of your target. This direction, when referred to magnetic north, is known as the magnetic azimuth. Other features of this compass for use in daylight operation are, first, this index line over the compass dial permanently aligned with the sighting slot and wire. This straight edge parallel to the line of sight. And this bezel ring, which with the crystal it contains can be rotated. When turned, the bezel produces clicks, and each click represents 3 degrees. A valuable feature for night operations. The first step in orienting a map with a compass consists of studying the map's declination diagram, which is found in the marginal information at the bottom of the map sheet. A declination diagram is placed on most maps to enable the user to convert a direction based on one north line, for example, true north, to a direction based upon another, such as magnetic north. This becomes less complicated once you recognize that 3 separate and distinct designations of north are encountered in using a military map. The first of these is called true north. A line from any position on the Earth's surface to the North Pole indicates true north. On a declination diagram, true north is symbolized by a star. However, when you use a compass, its arrow rarely points to true north because this arrow is attracted to or points to a magnetic area of the Earth which is located some distance from the North Pole. Magnetic north is indicated in the declination diagram by a line topped with half an arrowhead. Magnetic north is the reference used when working in the field with a compass. We can see then that true north and magnetic north are two of the three norths we must consider. The third designation of north on the military map is grid north. This is used when working on the map itself. As you know, the military map is printed with a grid, which is used for locating points on the map. For technical reasons, few of the grid lines which run from the bottom to the top of each map actually point to true north. Since grid lines are essential to use of a military map, their actual direction must be indicated for the user. Thus, the declination diagram includes a line which shows grid north. This line is symbolized by the letters GN. These, then, are the three norths encountered in map reading. True north, magnetic north, and grid north. To be of value to the map user, their relationship to each other must be known. This is what declination means, the angular difference between true, magnetic, and grid norths. In the declination diagram, the amount of this difference is indicated. It must be emphasized, however, that declination diagrams will vary with each map and may look more like this, or this, or this. When using a map with a compass, always begin by studying the declination diagram and analyzing the information it contains. Then apply this information to your individual situation. For example, in plotting a line on a military map, you will use grid azimuth, which is based on grid north. But a compass reading gives you magnetic azimuth. So before you can apply a compass reading to your map, you must convert from magnetic to grid azimuth. The declination diagram is used for this conversion since it shows the angular difference between grid and magnetic north, which is called the GM angle. The GM angle states the amount of declination and the direction from grid to magnetic north. In this case, magnetic north is a total of 15 degrees east of grid north. The GM angle will vary with each map. Here it is 5 degrees west, meaning that magnetic north is 5 degrees west of grid north. And here the GM angle equals 4 degrees west. Remember, the GM angle indicates only the declination or angular difference between grid and magnetic north. Now that we recognize the GM angle as expressing the relationship between grid and magnetic north, let us see how this information is used in the field. This man, as you remember, is about to orient his map using his compass. He has been studying the declination diagram and has determined the GM angle at this location. He now places the straight edge of his compass along any north-south grid line on the map and then rechecks the declination diagram for the GM angle. It is 5 degrees west, meaning that magnetic north is 5 degrees west of grid north. The soldier now carefully rotates the map, keeping the straight edge of his compass aligned with the grid line, until the difference in direction between the arrow of the compass and the black index line is equal to the difference in direction as shown in the declination diagram. In other words, when the map and compass have been rotated to a position where the arrow of the compass indicating magnetic north is 5 degrees west of the black index line, which indicates grid north, the map will be oriented. This is how the GM angle is used in orienting a map with a compass, and it is equally important in measuring directions once the map has been oriented. A direction is a straight line along which anything may be aimed, pointed, or moved. Direction is expressed in terms of angular measure, usually degrees. In map reading, the baseline used is always north. But which north is used? In the field, working with a compass, the baseline used is magnetic north. When working on the map with a military grid, grid north is used. In the field, using a map and compass, we must deal with two baselines in measuring direction, the magnetic and the grid. This is where the GM angle is important, for it is used to compute grid north from magnetic north or vice versa. To demonstrate how this works, let us assume that we wish to determine the direction of a point which lies out here. Direction, remember, is a straight line. So we draw in a direction line between our compass and the point with which we are concerned. In the Army, direction is expressed as azimuth, which is defined as a horizontal angle measured clockwise from a baseline. Azimuths are named for the baselines from which they have been measured. True azimuths from true north, magnetic azimuths from magnetic north, and grid azimuths from grid north. Since true north is not used as a baseline in determining direction with a map and compass, we will ignore that. In the field, magnetic azimuth is determined by sighting with your compass on an object whose direction you seek to establish. In this case, such sighting results in a compass reading of 80. This is the magnetic azimuth of our object. In converting this magnetic azimuth for use on our map, it is easy to see that grid azimuth is greater than magnetic azimuth by exactly the width of the GM angle, 15 degrees. Thus, to find grid azimuth for map use, add the GM angle of 15 degrees to the magnetic azimuth of 80 degrees, and you obtain 95 degrees as the grid azimuth. When magnetic azimuth is less than grid azimuth, add the GM angle. Elsewhere on Earth, the magnetic azimuth may be greater than the grid azimuth. So the GM angle of 15 degrees, as shown on the declination diagram, is subtracted from the magnetic azimuth. This gives us a grid azimuth of 80 degrees. To go from map to compass operation, you convert grid azimuth to magnetic azimuth in the same way. Here, grid azimuth is 95 degrees. Since magnetic azimuth is obviously less than grid azimuth, you will subtract the GM angle of 15 degrees from the grid azimuth of 95. Thus, the magnetic azimuth is 80 degrees. This, then, is how you convert grid azimuth to magnetic azimuth and vice versa. Study and practice with declination diagrams will enable you to use the GM angle for this purpose easily and rapidly in the field. Now that we have seen some of the principles involved in using a military map with a compass, let us see how they are applied in field situations. In the field, particularly under combat conditions, it frequently is necessary to determine a location which is not specifically identified on the map. This man, for example, sees this armored personnel carrier and wishes to report its location to his superiors. Although the APC is not in a position which is identified on his map, the soldier can determine its location by applying the principles we have just seen demonstrated and performing what is known as intersection. Intersection is used to locate points which are not designated on the map and is accomplished with a compass by sighting on the unknown point from two locations which can be identified. To illustrate, suppose that the APC we just saw was located approximately here. We first observed it from this road junction. To identify the point where it is situated by means of intersection, first we note our location at the road junction on our map. Then we sight our compass on the unknown position and record the magnetic azimuth of 145 degrees. Next, we move to a second known position from which we can see the APC, a position about 90 degrees from the first. We will use this road junction. Again, we note our position on the map and sight on the unknown point. This time, the magnetic azimuth is 205 degrees. We record this figure on the map, and our next step is to convert magnetic to grid azimuths. So we refer to the declination diagram for the GM angle. In this case, the total variation between grid and magnetic north is 5 degrees west. This is our GM angle. By studying the diagram and remembering that azimuths are always measured clockwise, we can see that magnetic azimuth is greater than grid azimuth. This means that we must subtract the GM angle of 5 degrees from our magnetic readings to obtain grid azimuths. The grid azimuths will be used to plot the point at which the APC is located on our map. For this plotting, a protractor is used. Protractors come in several forms, but all of them divide a circle into units of angular measure, in this case degrees. A scale of the degrees within a circle is printed around the outer edge. In the center of the protractor is an index mark. To plot the position of the unknown location on our map, we first place the protractor with its index mark directly over one of the points from which we sighted on the APC. 0 on the protractor must always face grid north, and the index lines must run exactly parallel to the grid lines on the map if plotting of the grid azimuth is to be accurate. When the protractor is precisely placed, we read the grid azimuth obtained at this location, 200 degrees, and mark this point on the map. Now, with a straight edge, we draw a line from the observation point directly over the 200-degree mark toward the unknown position. We then read the grid azimuth obtained at the other point, 140 degrees, located on the protractor, and mark it on the map. Again, using a straight edge, we draw a line from the observation position directly over 140 degrees toward the unknown location. The spot where the two drawn lines intersect is the location of the APC. On our map, it can now be read and reported as coordinates 387113. This is how you can use intersection with a compass to obtain the reportable location of an otherwise unidentified position on your map. But what if you are in an unknown location and need to find your position? How can you do this? It can be done by means of what is called resection. It is performed by sighting on two features which appear on both the ground and the map. To illustrate, you are somewhere in this area and need to know your exact location. From your position, you can see this church and this farmhouse, both of which appear on your map. After you have oriented your map, you sight on the church from your position and get a magnetic reading of 320 degrees. You note this on your map beside the church. Then you sight on the farmhouse and obtain a reading of 40 degrees, which you mark on your map beside the farmhouse symbol. Now you must convert these two magnetic azimuths to grid azimuths for use on your map, so you refer to the declination diagram. The GM angle is 5 degrees west. This, you can see, must be subtracted from your figures to convert them to grid azimuths. But even these grid azimuths do not enable you to determine your location on the map. For that, you must have back azimuths, which are in effect the azimuths back toward you from the points on which you have sighted. Back azimuths are obtained by adding 180 degrees to any azimuth which is less than 180 degrees, or when an azimuth is more than 180 degrees, by subtracting 180 degrees from it. With the back azimuths thus obtained, you are ready to determine your position. To do this, position your protractor on the map over the feature you first sighted on, the church. Then, on the protractor scale, locate and mark the back azimuth you have obtained for this location, 135 degrees. With this completed, remove the protractor and with a straight edge, draw a line from the point on which you sighted the church back toward yourself, passing through the point marked at 135 degrees. Then repeat this process at your second reference point, the farmhouse. Be certain that the placement of your protractor is correct. Then, on its scale, locate and mark the back azimuth you have for this position. It is 215 degrees. Remove the protractor and with a straight edge, draw a line from the point on which you sighted through the dot indicating its back azimuth and on toward yourself. Where the two drawn lines cross will be your location on the map. In the field, resection to locate your position on the map is performed in the same way. We have seen how to use a compass to orient a map, determine directions, and identify unknown locations. Now let us observe how it can be used to get you across country. This man is here, in this barnyard at 104673. He must get to Chickamuxon, here to rejoin his platoon. For tactical reasons, he must avoid this highway, which means that he will have to go across country to reach his destination. To use his map and compass to get him there, the soldier first places a straight edge on the map, connecting his present location with his destination, and draws a line along it between these 2 points. Next, he positions his protractor with its index point directly over his present location and its index lines properly parallel to the grid lines. He then reads the protractor scale at the point where it lies over the line he has drawn, in this case, 265 degrees, and notes this figure down. But remember, this is grid azimuth, and to use his compass to follow it, this figure must be converted to magnetic azimuth. The declination diagram tells the man that the GM angle is 5 degrees west, and magnetic azimuth is greater than grid azimuth. So he knows that to obtain magnetic azimuth, he must add the value of the GM angle to his grid reading. This results in a magnetic azimuth of 270 degrees, and the soldier is ready to set his compass for cross-country use. He first rotates the compass until the line indicating 270 degrees lies directly beneath the black index line. Then he turns the bezel ring until the long, luminous line on its crystal lies directly over the north-seeking arrow. Now his compass is set for the desired azimuth, and he is ready to move. The soldier will hold his compass where he can read it conveniently, approximately halfway between his chin and his belt. In this position, it has been demonstrated that the compass will not be affected by any metallic equipment he may be wearing. With the compass in place, the soldier now slowly turns until the arrow is directly under the long luminous line on the bezel. Now the azimuth, 270 degrees, will lie directly under the black index line and in line with the compass sighting wire. By following the line thus established out over the front cover, the compass user can determine his azimuth. If a landmark which can be kept in constant view lies on his course, it may be used as a steering mark. But even when no such reference points are available, the soldier, once he has set his compass, can maintain a direct heading toward his destination by frequently referring to his compass, checking his course, and resighting along the route. However, be careful when taking readings not to have metallic objects, such as the helmet, too close to the compass. At night, the compass may be used for simple land navigation in the same manner. For this purpose, it has certain luminous features not discussed so far. These are all visible in the dark and include the line on the bezel glass, the north-seeking arrow, letters indicating east and west, and an area directly under the black index line for reading azimuths. In addition, the compass cover contains two luminous dots, one at each end of the sighting wire. When the compass has been set, with the azimuth directly under the black index line and the long luminous line directly over the arrow, it is ready for night use. Rotate the compass so that the arrow lies directly under the luminous line. Then sight along the line indicated by the two luminous dots at each end of the sighting wire, and this will indicate your azimuth. If it is light enough to make out steering points along your route, make use of them. If it is so dark that none can be seen, send another man out along the azimuth line as far as he may be seen. Then sight on him, move to his location, and repeat this procedure until you arrive at your destination. If neither of these aids is available, continual reference to your properly set compass will accurately guide you to your goal. These, then, are the basic principles of using a map and compass in the field to determine locations or to guide you across country by day or night. Learn to apply them by study and practice, and you will be arming yourself with knowledge and experience which may someday be the key to a successful mission.